Aha. Okay, so as I am a one-man band, sometimes things do go wrong. At first, the audio wasn't working, and next, the chat wasn't working. So I think now we have everything working fine. I'm going to turn the gain down on my sound a little bit because it sounds rather loud to me. I'm not sure if it sounds loud to anyone else. There's no one here yet, so it'll be very hard to tell. Okay, slow start. But I think I'm ready. I thought I'd start by acknowledging the fact that David Deutsch was mentioned on the Lex Fridman podcast, the most recent one. Thank you to my friend Sean from Twitter, who let me know about this. And it was David Deutsch was mentioned in the context of Lex interviewing Aravind Srinivas, who I've heard of before because he's involved in creating chatbots, programming AI, that whole thing. But he's not a doomer. And he seems to have been influenced by the work of David Deutsch. He has read The Beginning of Infinity. The mentions that he makes of David's work in this interview are, so far as I can tell, and I've only listened to the first, 20 minutes, seem to me to be sound. He's talking about how knowledge is an open-ended quest and there will always be an infinite amount of knowledge left yet to be discovered. So that seems to me to be all quite right. And hey, great, more people are coming on board. I mean, Elon Musk is now following David Deutsch on X. So I think this is down very much to the work of Naval. Naval Ravikant has spread throughout the tech community an optimistic vision of the work that they do, and they don't have to be worried that what they're working on somehow has to be regulated and controlled for fear that it's going to take over the world, that kind of thing. And the reasons for that come not from just blind hope or naive optimism, but rather a deep understanding of computation, physics, and epistemology. And where can you find out more about that? The Beginning of Infinity, among other things. So, yes, David Deutsch mentioned yet again on the Lex Fridman podcast from a different person once more. This guy happens to be the CEO of Perplexity, which is kind of like ChatGPT, as far as I can tell. Similar sort of an idea. So, more power to people appearing on podcasts and spreading the word of whether you want to call it rational optimism, optimism in David Deutsch's sense, a way of countering the doomers and the prophets and the naysayers and the regulators and the authoritarians and the anti-enlightenment impulses that appear to be out there that will always be out there because people are fallible. I say always. Is that pessimistic? Not really, because it just is an admission that people make mistakes. And we can't expect everyone to always be committed to open-ended rapid progress. People will be born, learn certain things, and conjecture ideas, which are sometimes going to be very much against the idea of progress. That's just baked into what it means to be a person. Forgive my drinking of tea. It's just past morning tea time here in Australia, because I follow very much in the British tradition of these things. There are some loose ends I wanted to tidy up from yesterday's very fun Ask Me Anything live stream. And so before I get to any new questions that happen to arise today, and if you happen to be joining, please feel free in the chat just to ask me absolutely anything and I'll try and get to it. Was that Randy asked me yesterday via Twitter about a fellow called Dennis Noble, a name I'd heard, but I could not place the name. Where had I heard this name before? But the way in which Dennis phrased the question was about how maybe I should just go to the question itself rather than me trying to go off my failing memory of what the question actually was. So let me find your question, Randy. Apologies, Andy. A number of questions were asked yesterday, all of which were very interesting. And so we went for like good 2 hours and 15 minutes, which I've put up there in both the original live form and a slightly edited form to cut out the silences that are there when I'm talking. Now, I seem to have now lost that question. So what I will do is go to Randy's feed and see if I can find where he wrote the question himself. This must be very entertaining for people. Apologies. I can't find it. Oh, no, here we go. Randy asked me yesterday another question about constructor theory and said, can you comment on how Dennis Noble's ideas about purposeful or goal-driven action of biological systems, example, cells and organisms, in the context of constructor theory, can goals be objectively assigned to processes change in the state of the constructor substrate for an enzyme? If goals can be objectively defined, can this be a path to a better understanding of qualia and problem solving? I barely answered this question at all, and one reason is that I wasn't aware of Dennis Noble, or at least, although I'd heard the name, I couldn't place it in the intellectual context, so to speak. But I went away, did my homework, so to speak, because I thought the way in which the question was phrased, this goal-driven action of biological systems, it seemed to me to be standing in stark contrast to the selfish gene idea, where it's not goal-driven. Evolution by natural selection is a blind process of random mutations being selected, and those random mutations occur for any number of reasons, whether it be poor copying that's going on, or a far-flung cosmic ray strikes the DNA in just the right place at just the right time, causing an electron to ionize an atom, which then goes on to end up being a mutation. And so I went and did my homework, and I was very impressed to find that Richard Dawkins had debated this Dennis Noble guy. But I also thought to myself, because I don't know Richard Dawkins personally, but I have followed his work very closely for decades now. And he always had a policy. He used to say out loud, quite proudly, I will not debate creationists. And I will not debate creationists because although it's going to look wonderful on their resume, it does absolutely nothing for me. And no one learns anything. Now, of course, Dennis Noble is not a creationist, but the rejection of the selfish gene idea and a whole bunch of other things I went reading about, okay, what does Dennis Noble actually think? He was on the stage, and he's on the stage with the Institute of Art and now where is it? Yes, there is a debate between Richard Dawkins, that happened only last year, and Dennis Noble on the IAI site. So you can find that. The one that I watched was titled, you can find this on YouTube, Dawkins Re-Examined, Dawkins' Legacy. And Dennis Noble versus, if you like, Richard Dawkins. And they're talking about the selfish gene idea and evolution by natural selection in general. And it's a wonderful discussion, but I thought to myself, now, why would Richard bother? Because there are many people Richard doesn't even bother to engage with after all. And David Deutsch has a similar perspective. Why keep rehashing the same old tired ground, the old debates that we know have been long since resolved? We know certain things. It's like you can't keep arguing with people about the fact that the multiverse is the way in which we understand quantum theory. You can't keep arguing about realism. You can't keep arguing against solipsism or for the existence of infinities and for the existence of democracy. Now, we do these things, but at the high intellectual level, it's like, well, the argument has been had, the argument has been won, and the alternatives have been left aside as bad explanations. So my thought was, why would Richard subject himself to this? Well, as it turns out, Richard has deep admiration and respect for Dennis Noble. And why? Dennis Noble was his thesis examiner. So when Richard got his first PhD, it was Dennis who was listening and deciding whether or not he qualified for his graduate level degree. So this is one reason why. And Dennis Noble isn't any old critic. He is sophisticated and seems to have some understanding of the selfish gene idea, although by his own admission, he says he doesn't fully understand it. And that does come across in the debate that I watched that goes for about 50 minutes, and it's there on YouTube. And it's like two Jedi masters going at one another, but one of them, Richard Dawkins, clearly has a handle on things more than the other. But it's a very respectful tone, very humorous. You know, Richard says things like, I absolutely loved Dennis's most recent book. It is so beautifully written. It's cogent and clear. It's just that it's completely wrong. And so he was picking out a particular sentence from the book and unpacking it and saying why it's wrong. The fundamental disagreement between them comes down to Richard says that it is the gene that is the unit of selection, and it uses the environment, including the body in which it finds itself and the cell and all that kind of stuff, in order to get replicated. It is a replicator. Dennis denies that it even is a replicator to begin with, and then goes a step further to say that it is the organism or the body that is using the genes, looking them up, if you will, as and when required to build the proteins in order that it survives. So it's cart before the horse, in other words. I don't know what his motivation is because I haven't read a sufficient amount of his work. I've just listened to him talk. But we can judge people when they're set one against the other by the clarity of the explanations. And the clarity of Dennis's explanation left a lot to be desired. I was left with too many questions. Now, this could be my fault because maybe I'm not sufficiently aware of his work and of what his theory is. But Richard was explaining the theory very well that he holds to and that he discovered. For example, without using the term, he talked about substrate independence. Substrate independence. He said, we could take your genome, Dennis, And in principle, we could write it down on a piece of paper, preserve it under glass for 10,000 years. And in 10,000 years from now, we could recreate you, your twin. And Dennis's retort to that was, no, you couldn't. You would also need a cell. To which Richard, and I guess everyone in the audience went, well, of course, of course, that goes without saying. But that made me think that Dennis was just looking for a nitpicking way to disagree, not with the substantive point Richard was making, which was that the genome actually encodes information about how to build an organism, but rather wanted to pick him up on something he did not say, but went unsaid because, to me, it was implicit in his thought experiment that 10,000 years from now, we can build you, given your genome. Your genome contains all the information in order to recapitulate that organism. And it is the genes that are the things that are trying to, it is about survival of the genes. The genes that are most frequent are the ones that are most successful in a given gene pool, and so on. So I was none the wiser at the end of watching Dennis Noble explain or attempt to explain his alternative. He just seemed to be saying at times, well, there are unsolved questions here, there are unsolved problems here, to which Richard, of course, concedes, and everyone does, that we don't know everything there is to know about evolution by natural selection. But to deny that evolution by natural selection in the form of the selfish gene is the way in which we explain the diversity of species seems to be badly misguided. Reading further, my understanding is that Dennis Noble says things like mutation, for example, is not random. It's not a random process. Now, I don't know how he comes to that, but he says this. So all of these things that do cause mutations, radiation, chemistry, poor copying, I don't know how he gets around that. There's this idea that they're not random or pseudo-random. Nothing genuinely random in the universe, but of course, if your germline DNA is struck by a cosmic ray, that's as random a thing that can possibly happen in physical reality as can be imagined. Dennis Noble makes a big idea of the notion that acquired characteristics can be inherited, which is, no one these days really disagrees with that. It's just that's part of a wider understanding. Sometimes it goes under the terminology of epigenetics, that certain things can happen to your grandparents and that can affect your DNA, but it doesn't change the fact that the information is being transmitted via the DNA, via the genome. There's no other mechanism except that information is being carried via an information medium and then replicated. But he does reject, Dennis Noble does reject the gene-centered view of evolution. And he also rejects the idea that evolution is a gradual, incremental process. So therefore, he's on the side of Stephen Jay Gould. And those debates were well hashed out decades ago as well, between Richard and Stephen Jay Gould. So there's much to disagree with. And I think I understand that perspective. I don't understand Dennis Noble in particular, but there are people like that in biology. He's a biologist, he's a physiologist, he's a well-renowned physiologist, I've come to understand. He was one of the first to produce a working mathematical model of the way in which the heart pumps blood. So he knows his stuff at that level. But in terms of evolution, he seems to be getting things wrong, fundamentally getting things wrong. He thinks that the failure of biology to achieve certain things is an indication that the selfish gene view of evolution is itself flawed. So, for example, because scientists so far have not been able to create life in the laboratory, that therefore this view of having a gene-centered view of biology must itself be flawed, and I don't see that follows at all. There are many things we don't know in biology. We don't know how to make people live forever. That doesn't mean there's anything wrong with the gene-centered view of biology. So that's Dennis Noble. So hopefully that satisfies Randy on that point. I wanted to mention I was on AirChat. Join AirChat. If you've not yet joined AirChat, talk to me there. It's a great way to interact with like-minded people about any number of topics. Randy's on YouTube. Yes. Okay. So this thing about goals. Now I've talked about goals before, and in fact I've talked about goals here on a live chat before. And so I'm going to broaden things out now, because Randy said at the end of that question on Twitter, can goals be objectively assigned to processes changing the state of the constructor substrate for an enzyme? If goals can be objectively defined, can this path be a better understanding of qualia and problem solving? We can certainly define a goal, and this is what we want AI to do what we want it to. And you could say, that's the goal. I've got a pocket calculator. The goal might be for me to add up two numbers, and when it produces the sum, the pocket calculator has helped me achieve that goal. I might not know what the capital city of the United Kingdom is. I've forgotten for whatever reason. And so I go to ChatGPT and type it in, and it gives me the answer. My goal was to know what the capital city was, and at the end of the process of using the AI, I have found my answer. We can program AIs to achieve goals, to perform tasks. You hear a lot of people in the self-help community talk about human beings and people in terms of goals and tasks as well. You should have a goal-centered life. People who aren't driven by their goals are not going to achieve anything, and this kind of thing. And I think that is terribly misguided. It treats a person like a mechanism. Because if you set yourself a goal and do not achieve that goal, that's regarded as a failure. Rather than, which is often the case, you becoming more interested in a better goal. Better yet, don't call it a goal at all, becoming more interested in something else, something more important, something more fun. We should regard our circumstances being one of problems, many of which hopefully are fun, and animate our lives with the search for good explanations in our own lives, so that we can be more creative in finding ways to enrich our lives, physically, mentally, spiritually, whatever you want to say. And the pursuit of finding those solutions is open-ended, whereas a goal is a closed thing. Once you've achieved your goal, cap on top of that. And this is why one of the examples that people come back to is the Olympic athletes, who we can all admire. But imagine if, as a child, you see the person on the podium who is the fastest sprinter in the world, and you think, that's what I want to do. I want the gold medal at the Olympics, 12 years from now, and I want to be standing on that podium holding the gold medal for the fastest person in the world, over 100 meters. Now, whether you achieve that goal or not, it can be a recipe for unhappiness. After all, if you don't achieve it, you feel a failure. But if you do achieve it, we know. We know so many people in this situation, and sports stars are renowned for this. Sports stars are renowned for falling into deep depression because they haven't achieved their goal. Or when they do achieve their goal, there's nothing left for them to do. They go, what now? Because they've devoted their life to this one thing, rather than having problems and solving them and having fun along the way. Scientists can suffer the same thing. Scientists can make what they think is a discovery. The discovery doesn't get taken up by the community of scientists, and they can fall into a terrible depression that they feel as if they're going unacknowledged when they deserve greater acknowledgement. And this runs the risk of turning some people into cranks. A crank being, as I often say, a technical term for someone who pretends to have knowledge which they do not possess. That's not always the case. Sometimes great scientists whose work is not appreciated until after their death become very depressed because they think it should have been appreciated sooner, and they're right. But in any case, they shouldn't have the frame of mind where their goal is, for their pet theory, good though it might be, to make them famous, to make a deep impact on the world immediately, any number of these things. What they should be doing is trying to have fun. And if they're not having fun, they should be doing something else. We should all be trying to find the fun in whatever situation we're in. And that means having a goal-driven life is often not that. Having a goal-driven life works in opposition to this kind of thing and is different to problem solving. And so Randy has asked, if goals can be objectively defined, can this be a path to better understanding qualia and problem solving? Well, I'm not sure. I don't know what a path to understanding qualia could be. It's the same as the idea of consciousness. I don't know where to begin with that yet. My own conjecture, which doesn't get us far at all, is simply to say what we know subjectively is that we are conscious, and objectively what we see in other people is the best explanation is they are conscious too. And what separates people, human beings, from the rest of the species on the planet is that we generate explanatory knowledge. So therefore, are these two features or more features, consciousness, creativity, the capacity to have qualia, linked in some way? Throw in free will. Are all of these just different angles on the same mystery of what it is to be a person? And will it all be resolved once we figure out AGI? Perhaps. I don't know. But problem solving and achieving goals are, I would say, not necessarily the same thing, but can be regarded as opposites at the time. Because you may very well have the goal, I want to be standing on the podium holding the gold medal for the 100-meter sprint at the Olympics in 12 years' time. That might be your goal. And you do that to the exclusion of everything else, causing your future self, after you've held aloft that gold medal and for the warm glow of the following 2 weeks or perhaps 2 years, however long it lasts, yourself after that, you're condemning them to a kind of depression because you haven't thought beyond what problems will you solve then? What will animate you? Who did you step on, or what problems did you ignore the entire time you were training for this one thing? Now, no doubt there are sprinters and great sports stars who can avoid this trap of falling into depression, whether they fail or succeed. Perhaps for some people, having a goal for some time can be better than being completely inert. There are degrees of mistakes we can make in the way in which we organize our lives. One is to literally be inert, is to have no motivation whatsoever, be it a goal or a problem. Okay, I'm distinguishing between those two things. A goal is a thing that you think, I would like to achieve that thing because once I achieve that thing, I will be happy. That's my goal. I'll be happy, satisfied, or a better person, something like that. Whereas a problem is, this is the thing I'm interested in trying to find the solution to now. This seems like fun or important. Maybe both, ideally both. And I'm going to keep doing this unless, as Popper says, something else comes along that's more interesting still, a better problem. But in neither case have I got this goal. Am I fixed on this? Am I not going to be not distracted? Because that's supposed to be the virtue, right? You go when I go to a gym, and the way in which the trainers talk and the inspirational posters are up there, it's like, you must remain focused. You must remain committed on this one thing. And all the self-help people talk in these terms. Have a goal, stick to it, be fixated. Jocko Willink talks like this, But Jocko's an interesting person, but those kind of people are very motivating when you hear them. But really, when you listen to Jocko, he's having fun. He's a very different kind of character. He talks about discipline and, knowing what you want and that kind of thing. But he is also mercurial, by which I mean he changes his mind. And he talks about that in his books. So, you may well have this aim, this thing even that the military does, this is the target that we want to get and whatever. But they don't doggedly just go after that without regard for other possibilities. He's forever considering what might be a better option, which the goal-driven life doesn't account for. The goal-driven life, the goal-driven perspective is, here is this one thing that I am committed to not being distracted from, regardless of what else tries to intrude. And those things that are trying to intrude are giving you information about the world, especially if you think, I think I'd rather be doing something else right now. That's an important piece of information. It may be something you ignore. If you're trying to get fit, if your problem is that you're concerned that your heart isn't as healthy as it should be because that's what your cardiologist has told you, or that your blood sugar is too high because that's what the blood work from the pathology lab has told you and been returned to the doctor, or any number of things that could be causing you ill health, and therefore you have to some extent, do some things if you want to keep surviving that you otherwise hadn't included in your plan for your near-term life, then you're going to have to do things which you can call them goals if you like, but I would prefer to just call them problems to solve. And you can find fun ways of dealing with the unexpected. Things are going to intrude sometimes. And so, again, this is why I say admitting our circumstance is one of problem solving and not of goal achieving separates us from the machines. The machines are the things that achieve the goals that we set for them. And they will do it, so long as they're not malfunctioning, as well as we've programmed them to. And they won't disobey. Now, let me talk about air chat briefly. So come to air chat if you ever want to talk to me about anything. Voice to voice, Naval Rab accounts. There are a whole bunch of people there talking as they would kind of do on Twitter or Facebook posts or whatever, but it's voice. And I was talking recently about how people, in being unique, simulacrums of the universe as a whole. We each have our model of what's going on in the rest of physical reality, which kind of makes us like a universe. We have this internal universe inside of us, running a virtual reality rendering on this thing called our minds of the rest of physical reality. But each of us have a subtly different one. And so I pushed the analogy perhaps a little too far, but I thought I might share it now. And the analogy, if you like, is if we're going to talk about each other as being a universe, an individual universe, because as I say, we're modeling the universe. So there's this one-to-one correspondence between the contents of our minds in terms of our explanations of physical reality and the physical reality itself. And that one-to-one correspondence means if there's a universe out there, then there's a model of the universe inside of us. So each of us has a subtly different model, a different perspective on the universe. So what kind of universe are you modeling inside of your mind? Is it open, closed, flat, or something else? These are the cosmological terms. If it's a closed universe, then this means in cosmological terms, and what used to be thought, was that the amount of mass and energy in the universe would be sufficient, because it has gravity, to eventually stop the expansion after the Big Bang. There was a Big Bang, then an expansion of space. And then the expansion of space would eventually come to a halt and then collapse in on itself. That's closed. The analogy, therefore, to a person is, are you the kind of person who makes lots of rapid progress, such as all children do early on, and then eventually one day you just kind of give up and stop, and then you collapse and retreat in on yourself and go backwards and decline, become decrepit, and stop trying to achieve more? You're a closed person in the same way a closed universe eventually ends up in a big crunch. you're going to end up in a sudden death or something like that. Horrible thing to think about, but we hope that we don't end up in that position. That's the closed universe. Now, the flat universe, or the critical density universe, might be a better way of putting that, because other universes can be flat. We'll forget about that. So the critical density universe is where, on a knife's edge, the expansion of the universe is perfectly balanced by the amount of matter and energy in the universe, gravity, so that it comes to a stop. It doesn't collapse in on itself, but at the same time, it doesn't expand any further. And that causes a flat geometry. And it seems like our universe is extremely flat. And for a long time, that was a big mystery. It's like, why is the universe so flat, so close to the critical density? And the analogy there would be to a person who continues to make progress throughout the course of their life and then dies having continued to make progress, which is a preferable state to the first one, where they kind of went into a kind of regression. And the third kind is the open universe, which is the one where we'd like to get to. There's only one thing preferable to the open universe, except that the open universe is where you continue to expand forever. This is where the rate of expansion due to the Big Bang exceeds the amount of mass energy in the universe. So the gravity is insufficient because of the amount of matter in the universe to prevent the expansion from going on forever. And effectively what we've got there is escape velocity of all the galaxies, one from another, and eventually all the galaxies wink out from existence. So that would mean that you're going on forever to make more and more progress. But in a kind of way that means things are winking out of existence. You're becoming less and less populated with galaxies. And from your perspective, the light seems to die in the sky, which is what really will happen in our universe if it was like that. If the universe continues to expand in an open way, eventually almost all the galaxies will recede away from us. The night sky will become completely dark because all the other sources of light in the universe will have been expanded beyond the horizon from where we can see. But this is trillions of years hence, so no need to worry about it. The situation we're really in is not like any of those three, but most resembles the third one. In the third one, we had a rapid Big Bang, and then the expansion slowed down, but would never stop. We've achieved escape velocity. But in truth, what's going on, according to our observations, but for reasons we do not understand, is that there is an energy in space itself driving and accelerating expansion. And so rather than gravity causing things to slow down the expansion rate of the universe, there is something there that is more powerful than gravity, pushing things apart at an ever-increasing rate. This is the accelerating universe, and I guess that this is what the modern longevity-type people, the effective accelerationists, would call an accelerating person. If you could emulate that in your life, be the kind of person that managed to find ever more energy from an untapped source that we don't know about to make ever more progress ever faster, that's the ideal. So I pushed the analogy way too far there, and some people didn't like that. Okay, so questions that I missed yesterday. This one was hidden under a label that said probable spam, which I thought was so unfair. It's not probable spam. It's a great question. The question is, Sparsh Mathur is the asker's name. His question was, can the hard problem of consciousness be solved using Popperian epistemology? My main question is, can you ever really falsify any theory of subjective experience? So the first part of that, can the hard problem of consciousness be solved using Popperian epistemology? Popperian epistemology is a framework for understanding how knowledge works. So let's swap out the hard problem of consciousness for the hard problem of dark matter. Can the hard problem of dark matter be solved using Popperian epistemology? Can open-ended questions within evolution by natural selection be solved using Popperian epistemology? Well, Popperian epistemology is just a framework for understanding how other areas of knowledge, science and philosophy and mathematics and so on, manage to achieve what they do, what the process is, conjecturing ideas. So it itself is silent on any given theory within any domain. It just says that the way in which those theories are produced is via this method of conjecture, which is then criticized in some way, whether by the real world or by argument and so on. So I do not think that the hard problem of consciousness will come out of Popperian epistemology as such. It will begin somewhere in philosophy, the philosophy of mind, and then migrate, I guess, into some area of science, computation, physics, biology, something like that. I doubt biology because I endorse the idea that something like a mind is an abstract entity which is substrate independent. So biology then would become irrelevant to this question, but computation wouldn't be. And computation is a part of physics, and so it's ultimately a physics question. How can we incorporate this idea of consciousness? And who knows? I don't know. Can the hard problem of consciousness be solved using, you may as well say, X? And my answer is, I don't know. If I knew that, I'd be famous. And then Sparsh, you said, my main question is, can you ever really falsify any theory of subjective experience? Well, no, you can't, by which we mean if someone is saying to you, if someone comes along to me and says, I'm sad, there's no way that I can falsify their claim. Even if I was to put them into an fMRI scanner or take stick a needle inside of their brain and pull out a sample of their neurotransmitters and say, aha, the happy part of your brain is lighting up in an fMRI scanner, and according to the sample I've just taken, you have very high dopamine and serotonin levels. You must be lying about being unhappy. And that's not a falsification, because they might just be idiosyncratic. We don't know. We don't know enough about the brain to be able to say with such a high degree of confidence. And this is the problem. This is the hard problem of consciousness: is why does anything seem like anything at all? Why should, as Sam Harris says, reality be illuminated in the place where you stand right now? Why don't zombies exist? Now, my answer to this all comes down to, well, it may have something to do with the capacity to generate explanations. And that as soon as you admit the capacity to generate explanations, what you're doing is admitting that these entities, people, can have problem situations, can understand something about the present in order to hope for or dread about the future. And so this capacity to create explanations invokes a lot of consciousness or subjectivist sounding terminology. So it's hard to separate out those two things. But knowledge creation, the creativity part, is at least amenable to physics and epistemology and regular science and philosophy, whereas the consciousness side of things can only be experienced from the first person perspective. And so we do have these difficulties. But being unable to falsify something is no criticism. Remember that the overwhelming majority of our knowledge claims are not falsifiable. It's only in science that is a requirement, a necessary but not sufficient criterion for a theory to be scientific. Let's go back to the grass cure theory, okay? Or let's change it for a change. But this is based upon David Deutsch's grass cure theory. Let's say I say to you, next time you get a positive test for the coronavirus, go out and buy a dozen roses and eat them all. And that will cure your coronavirus. Now, that's a testable theory. Does that make it scientific? Of course it doesn't. Of course it doesn't. Just because something is testable does not make it scientific. Any crazy person wearing a sandwich board that says that next Tuesday the world is going to end has a testable theory. In order for something to be scientific, it needs to be both a good explanation of the physical world in some way that is testable. Okay, so The hard to vary criterion applies here. And one way in which in science something is particularly hard to vary is that it's testable, because the testability means that it makes predictions, and predictions are precise. And so we can, there's a very small margin of error for what it is. So when we say eat a dozen roses and you come back and say, my coronavirus was not cured, and I say, well, try 11 or 13. I'm easily varying it. Why? Because I've never given you the mechanism of action. Unless and until I can say why eating a dozen roses should cure the coronavirus, I've got nothing. I've literally got nothing. It's just it's crazy talk. It's a random hypothesis. It's easily varied. It's a bad explanation, a bad idea. What we want are explanations, and that's not that. Okay, so there was yesterday again, this fellow RP Richard was asking me again about wave particle duality. So let me go back to you, Richard, again, and he has a long question here. So let me let me read part of it. This is one of those questions where I was talking about earlier, where I do enjoy answering questions. I enjoy this kind of stuff, but it's one of those ones where, having talked about it so often, it's hard to know how to come at it a different way, going over old ground, so to speak. So Richard Pickett has asked, thank you yesterday for answering my questions. At the end of your answer to my second question, you mentioned the experiments that can be done in the lab to reduce light's intensity down via lenses to the point where the light will flash. What is the measuring device that picks up that flash, and isn't it susceptible to the measurement resolution problem I mentioned in my first question? The name of the device that picks up low-intensity light, such as single photons, is called a photomultiplier. A photomultiplier is used in astronomy, for example, in order to, which is basically, it's one of the very first charged coupled devices, which is another fancy word for digital camera. And so astronomers, we can thank the astronomers for the digital cameras we have today on the iPhone and smartphones and all that kind of stuff, because they were interested in developing buckets for light, ways of collecting light that were highly sensitive to even single photons. And so we have those now. And so photomultipliers can take in a single photon and then amplify it so that it can be seen by a single person as a flash of light. So that's the name of that thing. Does it suffer from the measurement problem? It's related to this idea of the measurement problem, in that if you were to do a twin slit experiment with a single photon, and you're not trying to detect which of the two slits that this single photon goes through, then repeating the experiment over and over and over again, you'll get an interference pattern using single photons. And they're single photons because you're firing them one at a time. And if you want to check at any moment, you can put this device, this photomultiplier, this thing that will catch the photon, so to speak, absorb it, and you will see that it's only ever catching one at a time. Now, the thing is that if you do put it in front of the apparatus, it destroys the experiment, because, of course, in order for the experiment to work, you want the photon to go through the apparatus, not to be absorbed by a device detecting photons, because once it does that, it's destroyed. The photon can only do one thing. It can't both be detected and pass through the apparatus. To be detected means to be seen, to be observed. And at first approximation, what a person does when they're observing something is shining light at things. So I can see my cup here only because the light from my room is hitting the cup, bouncing off it and reflecting into my eyes. When it comes to photons, things are much more difficult, because you can't shine a light at a photon. So what you have to do is to absorb the photon. It's the only means by which we can detect these photons, to have them collide with something else, perhaps with an electron, let's say. And so if you look at it in order to confirm, to check whether or not it actually is a photon, you can do that. But if you don't look and just allow it to go through the experiment, then you can see that it will produce a dot, that should be reasonably convincing, behind the apparatus on a screen where you live. You can look this up on the internet, right? Look up single photon interference experiments or single electron interference experiments. These things are done with whole atoms and molecules now, not just photons, so lots of small particles can be used in interference experiments involving twin slits or multiple slits, whatever you happen to like, and you fire them one at a time. So you absolutely know the electron is an electron. It's a particle. It's a bit of mass. It's got mass. It's got momentum. Yeah, oxygen atoms, uranium atoms, these things have been used in interference experiments to demonstrate that quantum mechanical effects can be seen with large aggregates of fundamental particles. Okay, fundamental particles are things like photons and electrons, but whole atoms are aggregates of those things. Okay, so and then Richard goes on, something about, I mentioned that light doesn't travel in waves because traveling in waves implies a medium. I agree that waves imply a medium, but don't we observe light traveling in waves as indicated in experiments like double slit? No. What we observe is single particles, and we can, as I just said, either you can choose to fire your single photon at a time, or you can choose electrons, or you can choose entire atoms, whatever it is. You know, you have no doubt, so to speak, that these things are particles that you are firing. Now, the word particle has to be understood as something more complex than what people normally regard. It's not point-like. You know, an oxygen atom is not a point-like thing. It has a size, it has a mass, but you can nonetheless fire it at this twin slit setup. But you know the oxygen atom is not a wave. You know what it is. You can even look at it under a scanning tunneling electron microscope to see it looks like a little sphere, fuzzy little thing, but sphere it is, approximately speaking. And you fire this thing at the apparatus, and it will end up on a screen behind the two twin slits. And over time, having repeated it again and again and again, you'll get an interference pattern. Why do you get the interference pattern? Not because it magically changes into a wave, but rather because if you fire it at the apparatus, it takes both paths. In fact, it takes all possible paths through that interference experiment apparatus. So the one you do observe and where it ends up can only be explained by the existence of entities you do not observe. Call those what you like. We call them the instances of the oxygen atom, each of which occupy a different universe, which is the multiverse. And the invocation of this that can be modeled by something like the Schrödinger wave equation, this mathematical description of all the possible places or paths or momenta of whatever the system is you happen to be looking at, like, for example, the oxygen atom. And the mathematics says that all these possible places or paths exist, so they're invoked in the explanation. They're required for us to explain what we do see. As the mantra goes, we're explaining what we observe in terms of what we do not observe. So a particle is a thing that is isolated around a point, but a wave is something that is extended throughout space, not isolated near a point. You can't be both simultaneously. You can't be both isolated around a point and extended throughout space, isolated around no point. That makes no sense. It's a strict contradiction, and quantum mechanics must also be rational and obey logic, the laws of logic. Richard says, my read on the people who are confused about the dual nature of light are actually just trying to see it as a discrete packet all the time, based on the idea that it must be a discrete packet because our measuring devices have a discrete resolution. To their consternation, a single packet of light or even electrons and buckyballs behave like it's traveling as a wave and creates the interference pattern. It appears to me that a more useful explanation is light is energy, and when travels through a medium, so wave behavior, and when it's measured, it's absorbed into something like an electron at a discrete resolution, which resolution is based on the properties of the things absorbing it, i.e. electron, not the light itself. Neil Evans has responded underneath that, a single word, shadows, and I would yes, encourage you to read chapter 2 of The Fabric of Reality, Shadows, where it should clear up a lot of this. The confusion is absolutely on the side of the people who endorse this idea of wave-particle duality or the dual nature of light. What we are after are explanations of reality. And just because a good explanation is an explanation you do not prefer is independent of the truth of that explanation. There are certain things we might not like about reality, but the fact is that light and electrons and matter, the standard model of particle physics is about particles, not about waves. Light does not travel through a medium. That's been demonstrated as well. It can travel through the vacuum of space. And this was settled even before quantum theory, really. There was the suggestion there should have been an ether. But it's just not true. So when light does pass through a medium, like air or glass or water or whatever it happens to be, it tends to get absorbed, degraded over time. Photons are interacting with matter. So it's not a vibration of the matter, which is what a wave would be. It's a particle that moves through the matter and can actually physically collide with the matter. A stream of particles is not a wave. And that's as cut and dried as we can get in science, I would say. We know what photons are to a good first approximation, and well enough to categorically rule out that they're waves. In higher dimensional space, when we talk about what any object seems to be like in a single universe, when viewed from a God's eye perspective across the multiverse, then we can talk about it being extended across the multiverse in a continuous way, like a wave. But no one ever experiences the wave. You are a wave in that sense across the multiverse. But of course, you only have the singular experience of being a person, not the copies of yourself that are extended across the multiverse. So we have to be careful to keep tight our explanations of what is going on in these situations. It's simply not the case that particles are waves, ever become waves. It's an old idea, this wave-particle duality. It violates logic and the law of the excluded middle. It's a retreat from rationality, and it wants to have things both ways. It also tries to ascribe consciousness at times to fundamental particles. For example, there was a popularizer of science in Australia, he's still around, Dr. Karl, who would say seemingly clever things were more like deepities, another pejorative term used for something that sounds like it's really intelligent, but in fact is vacuous. And he would say a photon is born as a particle, lives as a wave, and dies as a particle. How does it know when to turn into a wave? And how does a particle turn into a wave? Well, these questions just weren't answered. It just sounded like a nice way of getting around this idea of how to explain what's going on in the twin slit experiment. But as I agree with Neil there, just read chapter 2 of The Fabric of Reality. And if you're not persuaded by that, I mean, you can ask more people, read more widely, or, stick to your guns, I suppose. But I prefer an understanding, and that helps me understand. I want to understand what's going on in these experiments. Okay, let's go over to YouTube here now. Brad Ingefard, you mentioned fun. Can you expand on Deutsch's fun criterion? Probably not expand on it. Look, it's nothing more than there are many ways of coming at this, and probably the best way for anyone who's interested in this is literally to look up David Deutsch, the fun criterion, where he is in conversation with Luli Tannant about this idea of David's of finding the fun or pursuing fun or doing things that are fun. But it's not a vacuous kind of fun. It's not a nihilistic kind of fun. It is solving your problems. It is when the explicit, implicit, and inexplicit knowledge that you have in solving problems comes together, and you're just in a kind of flow state where you are flourishing. You're not coercing yourself into doing things that you don't want to do. So the fun criterion is insightful for many people who, I guess, have been brought up in authoritarian ways of living their lives and thinking, well, I've got to get this task done. We were talking about goals earlier. I've got to try and achieve this goal. I've got to do this work for my boss and get this particular thing done. Rather than just focusing on what it is they're interested in and curious about, what they find fun. Because you will find, and this is the great difficulty people have, because people have been indoctrinated and trained at school to work hard. And if you've been trained to work hard, then you will feel guilt if you're not working hard. That whole idea of the Protestant work ethic, that people tend to feel great guilt if they're not working hard, if they don't feel as if there is blood, sweat, and tears that comes along with their day-to-day routine. That if at the end of the day you're not exhausted, if at the end of the day you can't point to this number of bricks that you have moved, or this many thousands of words that you have written, or this many speeches that you have given, or this many sales that you have made, if you haven't met your targets and your metrics, then in some way you're a failure. That your life needs to be set up in such a way that fun is nothing but a luxury for other people, or what you do when you're not working. And even then, it comes down to distracting yourself from the stress of your life. And so fun amounts to, I don't know, people doing things that they're not really interested in, but are distracting them from what they're going to have to do tomorrow. I guess an argument for why people turn to alcoholism, that kind of thing. Rather than being engaged fully and completely in the life of the mind, for want of another word. There are things there that you're really curious about and interested in, and they're the things that you should be pursuing as much as you possibly can, to find fun in doing those things that you, even if no one was paying you, you'd still be doing. Now, this is the luxury that I understand few people can enjoy. It's true. Naval Ravikant has talked about this, how what you want is to be unemployable. In other words, someone comes along and offers you a job and you say no matter how much money it is, because you've got better things to do. You're having fun. He talks about you don't want to be a slave to a wage or a salary. Now, he says all of this, and people sometimes do not hear the second half of this. And he's talked to his co-founder of AngelList, Nivi. And they've talked about this. And everyone hears that first part. It's like, you don't want to be stuck in a job at a company where you're just earning a wage week or fortnightly or monthly. You want to escape from that. You want to be independently rich and wealthy. But the second part of that the people ignore is, he says, but sometimes it's absolutely essential to at first do the hard work and make the money in order to get to a place where that can be a possibility. Naval himself is an example of this, who studied hard and worked hard and came from very little to become one of the wealthiest people in the world. This is an argument for what you may want to aspire to, not a goal, problems you might want to solve, fun things that you can find to do along the way to make ascending, for want of another word, the ladder of life easier. To not get stuck in a rut where you're just moving the bricks day after day, or writing the words in the articles week after week, or making the certain number of sales. But if you are doing that and you think there's no way out of this, well, make sure you're doing something else that you're finding fun in the meantime. That thing, and I wrote a tweet storm on this, something like, eventually turning your hobby into a career turning your career into a body of work and then your body of work into a legacy. So if you're listening to me and you do not have, and you're stuck in one of these jobs where you think, if only I could do whatever I wanted every single day, but I can't, I've got to dig this ditch, but I can't, I've got to write this article, but I can't because I've got to write this code for my boss, but I can't because I've got to cut this hair, but I can't because I've got to drive this bus, or whatever it happens to be. And you think it's all very well for those people to talk about living the life where they are not coerced by a boss, where they've escaped from the weekly or the monthly grind. It's all very well for them. No, I've certainly absolutely been there. But in every spare moment that I had where I wasn't working for someone else, where I wasn't doing the thing that my boss required me to do, I was doing the thing that I found fun. I was putting effort into that, hour after hour, day after day, week after week, year after year. Now, some people will say, well, good for you that you had the energy to do that. You have to, at times, problem solve. You have to find time, in my case, you have to find time to exercise. You have to find time to walk and clear your mind. You have to find time to read. You have to find time to get certain things done. Some things are necessary to figure out that life is about problem solving. And we are all, at the moment, in a transitional phase as the AI transformation occurs, between where, for many of us, a lot of our work is laborious and toil. David Deutsch quipped the other day on Twitter, just stop toil. Exactly, just stop toil. We need to somehow escape from a society which is set up where people are toiling, engaging in laborious work, tasks, obeying their bosses, structuring society in such a way that we have a hierarchy between boss and middle management and the serfs. We need a way in which everyone can pursue their creative interests. But at the moment, we are singularly not set up that way because people are indoctrinated at schools into thinking that working hard is a virtue, which means that it dampens curiosity and creativity. Because people begin to feel a sense of guilt for not working hard. They're told by their parents when they go home, have you done your homework? They're told by the teachers, and make sure you got your assignment ready to hand in by this Friday. Make sure that you're studying for the test that's coming at the end of next month. All of it's hard work. And so they go into the workforce thinking the way to succeed is to do hard work. I could talk about that for ages. The idea that the more difficult the subject is at school, okay, the highest possible levels of mathematics, and the more boring it is, the more it should be desirable. How bizarre is that? Children are often encouraged not to take on the subjects at school that they're interested in within the very fixed confines of the small amount of freedom they do have. Hey, you can choose what subjects to study, but even then they are coerced to not take subjects that they otherwise might be interested in. Little Jane might want to study dance and creative arts, and the parents are saying, no, we want you to be a doctor. You need to study chemistry and mathematics. So poor little Anne does that instead. Her creativity dampened, her enjoyment of school, for what it possibly could have been, destroyed. And just maybe, little Anne rebels and fails her subjects and does something else after school anyway, so that never helped, whereas she may very well have succeeded. But yeah, so there's much to say on this topic of how it is that the fun criterion is an ideal we can all have operating in our mind to some extent, but many of us, yes, admittedly, spend rather a lot of our day engaged in things where it's a very difficult problem to solve of how to turn this laborious work that you are required to do in order to get paid, in order to feed yourself and your family, into something fun. The only advice I have is that there has to be time in that day or that week, however long or short, where you can engage with your own passions and interests and curiosity and be creative in that area, because we are all unique, as I say, we're all our own universe. And if you devote yourself passionately to one thing, people tend to notice. And not only that, the problems that you solve for yourself can be generalizable. They can help others as well. And so don't downplay yourself that your passionate interest in this strangely esoteric thing is of no use to anyone at all. You don't know that. We cannot predict the content of future explanations. We cannot predict the way in which your peculiar love for 18th century Russian poetry might have very important consequences for the future. We can't predict how. We can't predict the future growth of knowledge. Okay, going back over to YouTube. That's fun. Randy, again, hi, Randy. Can we communicate with we can communicate with other people versus which through teaching and rational criticism. Can we accelerate the expansion of multi-person verse conjecture and criticism of dark energy here? Yes, I guess so. The amazing thing is that we can communicate with each other. We are, as I like to have said, pushing the analogy perhaps too far, separate universes, and one person is different from the next person as one species is from another species, and that might be underselling things as well. You know, you take two chimpanzees and they're very similar. Take two cats and they're very similar, even though cats have different personalities, and so do chimpanzees. But people, wow, I mean, not only different personalities, but just it's almost a miracle. It's not a miracle, but you know, it's miraculous that we can communicate at all because of how different we are from each other. And so this leads Popper to say things like, it is impossible to speak in such a way as to not be misunderstood, because we are, each of us, speaking subtly different versions of the English language, if English is the language in which we're communicating. And so we always misunderstand each other. Randy's gone on to say, could you discuss your reasons for not agreeing with Roger Penrose's claims that human brains cannot be entirely computational in their function? Why cannot quantum information play a role in brain function? Well, it could in principle. It could in principle. And, well, the first thing to say is Roger Penrose is wrong as a matter of physics that human brains cannot be entirely computational in their function, whatever that means, because of the universality of computation. The Church-Turing-Deutsch principle is a principle in physics. It is what all other laws of physics must be compared to. Could it possibly be false? Yes, in the same way the second law of thermodynamics could be false, the law of conservation of energy could be false, general relativity could be false. Everything could be false, and in the final analysis will be false. But as of right now, our best understanding of reality tells us that all physical processes can be regarded as computations. And the human brain, what it's doing, can be regarded as a computation. That's just a principle. It's the law of physics. And so he's rejecting that, but not inserting anything better in its place. Now, to take it a bit further, I think Penrose, along with Hammerhoff, forget his name, neuroscientist, I think, who talked about how there might be microtubules in the brain which enable consciousness to arise, something to that effect. It's a quantum effect. Well, it's related to this notion that could the brain be a quantum computer? Well, we can't rule out that yet because we just don't know how the brain manages to achieve consciousness and creativity and all that sort of stuff. So everything is still on the table, so to speak, so long as it doesn't violate the laws of physics, which rejecting the idea that it's computing things would do. Now, I guess you can do that so long as you have a good explanation. But I prefer to start with the best of what we understand now and see where that will take us, as far as it will take us. It's like saying, is there life out there in the universe beyond Earth? You know, are there alien civilizations? Well, I would like to begin at least with the assumption that whatever life is out there obeys the laws of life and biology that we've hitherto discovered, namely evolution by natural selection. In other words, there's not life out there that has appeared on a planet because God magically put it there. Now, you could say that, but I don't think it helps. And I don't think it helps in the search. Because if instead you go down the road of our best explanations now, at least you can narrow in on where to look, among other things. You can say, well, life, if it evolves by evolution by natural selection, requires some sort of information to be passed on from from parent to sibling, not sibling, from parent to child. There needs to be generation, so that's genetic material. If that's what life is elsewhere, however exotic it might be, it's going to be some sort of information carrying thing. That's what life is. So it's a good place to start there. So therefore, we need to look in places where information can be preserved. In other words, looking inside of, and David Deutsch's example is looking inside of a quasar jet for alien life is probably not the best way to go. Better to look in, the Goldilocks zone around a sun-like planet somewhere in our galaxy, metal rich and so forth. Okay, that would be more promising. We have ideas, we have constraints, parameters that we can put around these things rather than just it being free for all. Parameters set by our best understanding right now. And in the same way, if we want to understand how the brain is achieving what it's achieving, why not start with our best explanations now of what computation is, the universality of computation, that kind of thing? I'd rather start there than say, let's throw that in the bin and let's go for some completely different idea, which itself is not a good explanation. There are no good explanations of the brain, but at least we can have parameters placed around what we might be looking for, parts of the brain which are giving rise to certain things, processing things in a certain way. Maybe we can come to understand that a bit better. As far as I understand, we're a long way from really understanding anything like, people talk about the neural correlates of consciousness and so forth, which I don't think is really going to help us to solve the problem because it's a philosophical problem at the moment. But as for the human brain, for example, harnessing quantum mechanical effects in order to achieve what it does, the great difficulty I see there is one of engineering, because the best models of quantum computation that exist out there right now appear to be using qubits entangled at temperatures very close to absolute zero, minus 273 degrees Celsius, fractions of a degrees above absolute zero, by the way. That's to enable them to perform the computations without, error exploding everywhere. There could be a way in which, just as we have higher and higher temperature superconductivity, maybe there'll be higher and higher temperature quantum computation, but we're not there yet. And I don't see a way, but just because I can't see a way doesn't mean it's not possible. But I would just observe that this would be a clue that if it can't be done in the laboratory, okay, quantum computation at room temperature, that maybe, just maybe, it's not being done inside the neurons of your brain. But who knows? We just don't know. I'm not dogmatic on this point. It could be possible, but absent a good explanation, there's no reason to place bets anywhere, except to be constrained by what we know at the moment. So yes, I think that answers that. Let me go to Twitter one final time. And Adam Quirk has asked me, for someone with a pop sci understanding of quantum physics, can you recommend a good book or any media that introduces the subject in a bit more depth? Well, of course. Of course. Of course I can. It's all I ever do. Adam, read The Fabric of Reality by David Deutsch. Read The Beginning of Infinity by David Deutsch. By far and away, heads and shoulders above every other pop science book, because they're not really popular science books, but they will give you an understanding of quantum physics if that's what you want. Now, you then say a bit more depth. Well, I don't think, if you read chapter 2, Shadows, and then chapter 11, 10, the multiverse and the beginning of infinity, that's more than enough depth. And then if you still want more, I would go to David Deutsch's papers, his academic papers, which are not a super difficult read. Look at interviews with people like Sam Kuipers or Chiara Marletto on the same topic, or David Deutsch himself. There's lots of stuff out there on YouTube. Things that I've produced over the many years that I've been doing this now as well. So if you just want to pop science understanding, if you want to go deeper than that, well, it depends on how deep. I mean, once you want to go beyond that, then you want to get into the formalism of quantum theory. Then you're talking about, picking up textbooks and that kind of thing. But all the textbooks are framed in terms that are not to do with Everett. Read Everett's paper. Read Hugh Everett's original paper on the multiverse. The formalism can come along for the ride, learning as you go, if you like. Learn a little bit about matrices, perhaps, would be a way to go. Learn a little bit about differential calculus. It depends on how much you know about the kind of mathematics that would be used in quantum theory. But those things serve to help you make predictions and to solve certain problems, and they're for the professional physicist. I think you can get a good understanding to the point where you can explain it to other people without needing to refer necessarily to formalism. I sometimes do, but it's not usually necessary unless you're talking to another physicist about some of these things. So can I recommend a good book that introduced the subject in a bit more depth? I say both of David Deutsch's books. Brian Cox's book was reasonable on this. What was it called? Let me get check. Brian Cox's books it's just called Quantum Universe. Why anything that can happen does. Correct. So he's throwing in a little bit with the idea of the multiverse. I don't know if I think he kind of avoids the word. One of these physicists who still is basically all there, but not quite, for whatever reason. And so, Quantum Universe by Brian Cox, and there's some second author. Jeff Forshaw. Oh, yeah, it's his colleague from the university that he's at in England. Yes. Okay, I think that exhausts our questions for today. Thank you for those who tuned in and who asked more. We'll do this again soon. Until next time, bye-bye.